So formally I'll start now. So good evening, everyone. So this will be our second tutorial session for the NPTEL online course on mechanism and robotic kinematics. So today we would our agenda is like I will be focusing a lot on MATLAB, and also we'll talk about one alternative open source software called GNU Octave. So what we'll do is I'll first, before we start, we'll go to discuss the week 1 assignments. And then we'll start. Yeah. Okay, so I think we'll start with the questions that was discussed in.
It will cross the recording thing with different dialogue on top.
Okay. Okay, so we'll start with the first. With only some of the solved problems we'll do. I mean, only the questions will involve some certain computations. So. Assignment. So you'll only do these solved problems, I mean, which requires a solution, which are not just objective questions. So the first question is that we had a structure something like this. Rather, yeah. So these are two revolute joints, member 1 and member 2. So we are asked to find what is the degree of freedom of this kinematic chain. So kinematic chain is essentially what you call it's just a way of representing mechanism by virtue of yeah. So kinematic change is essentially links and joints. It's a combination of links and joints which form a mechanism. So that is what essentially this kinematic chain is. Now, in this case, what we have to do is we are asked to find the degree of freedom of this kinematic chain. So at the outset, what is the dimension of the problem?
2D, right?
Yeah, exactly. The dimension of the problem is 2D. So which means the formula that we have, formula for DOF, is 3 into NL minus 1 minus 3 number of joints plus summation of degrees of freedom from first to the last joint. So now let's start with how many links does this have? So this has this straight link and one is this curved link. So the number of links is 2. And joints we have is, this is one revolute joint. Come on, sorry. Yeah, so this is one revolute joint and this is the other revolute joint. So which means that we have 2 revolute joints. Right? And then And for each joint, so for each joint we have say I is equal to 1 to j. So for F1, which is the first revolved joint, the degree of freedom is 1. Likewise, for second revolved joint, also degree of freedom is 1. So effectively, you have two degrees of total degrees of freedom allowed by the joints. So therefore, DOF is equal to 3 into 2 minus 1 minus 3 into 2 plus 2, which is essentially 3 into 2 minus 1 is 3 minus 6 plus 2, which gives us minus 1. So that is the answer. So degrees minus 1 means that this mechanism is over constrained. Yeah, any degree less than 0 means it's just meaningless. So essentially, it's an over constrained system. So yeah, we cannot have any such. So what happens in mechanisms? We always consider all the links to be rigid. That is the first thing to. It doesn't mean that if this body is say deformable, then it does not mean that we have degrees of freedom -1 or so. Then it can deform anyway. But the thing is, we are not allowed to have any non-rigid links. All the links must be rigid. So which means that by that, from that perspective, the only this can neither bend, it cannot bend, it cannot say undergo. In this case, it will only say it cannot undergo any bending or so. So because of which we are already, yeah,
I
yeah.
think I think it's like the relative moment between 2 points is always constant. That's what, like when you have
Yeah,
minus
but the
one.
thing, no. Here the thing is -1. It actually does not make any sense. Yeah, so that's it. Although it's -1, but it just means that this mechanism is over constrained. So that is how we
Over
classify.
constraint means it is just a rigid body like that, right?
Yeah, so if it were a rigid body, then the degree of freedom would have been say 0
It's
actually.
okay.
Yeah. So mechanism with 0 degree of freedom is called 0. DOF 0 implies structure, and then DOF greater than 1 implies um, then it's what we call as a mechanism essentially. And degree less than 1, at less than 0 implies that it's just over constraint. It does not have much what you call meaning, so to speak. Yeah. So now let's go to the to another to question number. I mean, third question of the assignment. So here it says that find the degree of freedom of the kinematic chain, which is suppose we have a kinematic chain here, something like this. And so this is degree of. Yeah. So in this case, what will be the DOF of this kinematic chain? Now the thing is, let's start with how many links we have. So number of links is, one is this link. So this we call as a quadruple link, which means it has 4 joints. And then this is the second link, third link. This is the fourth link. And this is the fifth link, sixth link, sixth, seventh, eighth. So there are 1, 2, 3, 4, 5, 6, 7, 8. There are 8 links. And how many joints we have? Joint is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 joints. And how many, now let's count about the degrees of freedom for the total number of joints. So all of them are revolute joints. So all joints are revolute. So other name of revolute is called as hinge joint. Yeah. So which means that it will be just 1 degree of freedom per joint into 10 joints. So it is 10 degrees of freedom. So the DOF here will be 3 into 8 minus 1 minus 3 into 10 plus 10. So this comes out to be 3 into 7, 21 minus 30 plus 10, which comes to be 1. So the degree of freedom is 1. Okay, so now we move to the next question. In this question only, like there was a separate, I mean, just an additional question just for this is how many ternary links we have. So ternary links are links with 3 joints. So how many of them are there? Can anyone of you please say?
Two, three, four. Can we say that?
Yeah, so how many ternary links it has? Like ternary is link with 3 joints. So which link has, say, link number 2? So
Yeah,
which
two,
joint, which link this is?
2, 3, 4 has like 3 joints, right? 2, 3, 4.
It
Three,
has
four.
1 and 2, right? Just 2. So this is called a binary link. So which one of this is a ternary link, like link with 3 joints? So like say body number 1 or the link number 1 has how many links, how many joints associated with it? So see, this is the link number 1, right? So it is link, I mean, joint 1, joint 2, joint 3, and joint 4,
Okay.
right? So which means this is a quaternary link because it has 4. So now by that logic, which one will have 3?
2, 8, 3 is one. 3, 6, 4 is one more.
Oh, the thing is 3, 6, 4 are the joint numbers. The
So I should tell you 5, 4, or 5.
Yeah, so there are 4 and 5. Yeah. So it means 2 ternary links we have. Okay. So let's go to the next question. Okay. So now we go to the next question. Question number 5 as per the assignment. So here we are asked to find this is sliding over something. And, right. So now let's find out the number of links. So all this can be clubbed, right? All of them. These are all rigid parts. So they can be just called as ground. So ground is one link. Ground, we always have to include ground as one of the links. And this, what we call, the serial number starts with 1. So ground is always the first link. Now let's go to the second link. So this is the second link, right? And this body here is the third link. This body here is the third link. This is the fourth link. And this is again a ternary links of fifth. And this is the sixth link. This is the seventh link, right? And this is an eighth link. And this is the ninth link. And also this is our 10th link. Now let's go to the joints here. So this body here can slide along this direction back and forth from this position. So which means that this is a prism joint. And also this here is a revolute joint. So we have one revolute joint. And here we have, these are all revolute joints. So R. And what you see here is at this joint, we have three links, links 7, 8, and 9. And as we recall that a link can support only two link, I mean, a joint should support only two links at the same time. So which means that this link, this joint here is a degenerate. So it degenerate R joint. So which means that there must be R plus R. There must be two R, just in a sense that they are just separated, so to speak, and the distance between the separation we bring close to 0. So which means that we have two RR here. So that, yeah. So at this point, it's there is one connecting links 5 and 8, and the other R connects link 9 and 8. So this is what is called degenerate. If at any joint, if you have more than two members, two links, that means that that link there is a degenerate. So it must be one more at the same time, right? So now these are RR links, and here based on, since it can slide, so it means that we have one more prismatic. So it's one more P we have here, right? And now in this case, what we have is here also it can slide. So which means one prismatic and there is one revolute. So one revolute. So RP here. And here these are fixed. So it is just our what we call revolute joint and one revolute joint. So now let's count. So number of links will be 10. And number of joints we have PR means 1, 2, 3, 4, 5, 6, 7, 8. So let me just mark it. So it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 joints. Now, mind you that P and R have both one DOF. So which means that summation of I is equal to 1 to J. I can also write it as sometimes NJ or N. I just will use interchangeably. So 1 to NJ is equal to, it's nothing but 1 into 12. So it's like 12. So therefore, the DOF number of degrees of freedom is equal to 3 into 10 minus 1 minus 3 into 12 plus 12. So it's 3 into 9 minus 36. So it will be 27 minus 36 plus 12, which comes to be 39 minus 36, which is 3. So we have 3 DOF for the system, right? And now we'll solve one more question and then we'll start our MATLAB session. So let's pick up this problem. And then we have this will also slide over the other surface. And here we have okay. Now let's start counting the number of links here. So I mentioned that all the rigid components always form the ground. So these are form a ground. Just not to confuse. So let's have this, and this here. Yeah, so this form a ground. Ground means link number one, right? Now this will be the link two, and this is the link three, fourth, fifth, sixth, seventh, eighth, and you have this nine here, this straight line. Just this is nine, and this is 10th. So let's count again. Ground one, then this second, third, fourth, fifth, sixth, seventh, eighth, ninth, and 10th. Yeah. So we have NL is equal to 10. What about number of joints? So let's look carefully. So this body here can slide. So it means there is one prism already there. And at this point, there is one revolute. So R, this is the revolute. And as we recall that at any joint, we cannot have more than two members. So this is also degenerate. So it's R plus R. This is also revolute. And here also, this body can slide, which means there is one prismatic. And also we have at one joint, we have two, which implies that there must be R plus R here as well. And this is one more R. And here as well, we have similar things. So there are two R joints at one point, and this it can slide over this ground. So we have this prismatic, and then we have R plus R. Right. So now let's just count it. So this is P 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. So we have 12 joints. And we recall that all are R and P, which means the summation of the degrees of freedom will be just 1 into 12. So it's just 12. So the number of DOF is equal to 3 into 10 minus 1 minus 3 into 12 plus 12. So 3 into 10 minus 1 is 27 minus 36 plus 12, which comes to be 39 minus 36. So degree of freedom is 3. Okay. So I believe that we'll start solving we'll start with MATLAB today. So I just wanted to get heads on with MATLAB from today onwards. So at first I must tell that MATLAB stands for uh, Matrix Laboratory. So I mean, let me know who all have some prior experience with MATLAB. Please just raise your hand. So I'll just. Yeah, so who all have prior experience? Yeah, just one, or apart from Dinesh. Okay. So Peru Malaswamy. So I have you have unmuted. So I mean, by chance, like, would you want to say something about, like, do you have some experience with MATLAB before? Okay. Yeah.
Let's
So Mat.
assume they
Yeah.
don't have any experience and go from there.
Okay. Yeah. Yeah. So MATLAB is essentially a commercial software. So I must tell beforehand, it's a commercial software and also requires a huge license fee. So some of the alternates are GNU Octave. So it's a software with so it provides as much features as possible. You through MATLAB, it's I mean just and the syntax is also so the syntax is the same as MATLAB. So we can use either of one of the two, maybe uh, MATLAB or GNU Octave. There is another software called FreeMat. So FreeMat is also another software which also has MATLAB-like features. Then again, the thing is with MATLAB, it is on its own. Like all the most of the features are always in MATLAB. The rest are just some approach towards to MATLAB. So that is essentially. So what I'll do is maybe I'll just share the screen and the other screen, and I'll just give some information about. So this is one such software that I was talking about. It's called GNU Octave.
You are not
It
sharing the screen, Krishna, by the way. I don't know.
okay. Okay, let me share again. Yeah, now is it visible?
Yeah, I don't know. Yeah.
Okay. So this is one such software which is yeah, which is very similar to MATLAB, and all the even the syntactically it's quite as close to MATLAB as possible. And it's a free software, so we can install and then also run it on our own systems. So what I'll do is I'll just maybe right now we'll download it and we'll just. So let it run. And there is another software called FreeMat. But the thing is with FreeMat, uh, I believe that the updates is, as you see here, it was updated long back in 2013, and it's not much. It's not being updated frequently as of now. So let's just search what are the other alternatives. So these are the two I'm aware of.
Scilab as well, right?
Yeah, the thing is with Scilab is it uses a different format as well.
Right? Okay.
So .sci, right?
I'm
Yeah.
just like telling you different things which I know. Yeah.
Yeah, yes, yes. So Scilab is there also, Scilab. But the thing is, Scilab has some slightly different syntactical form. So it becomes tough then. Like you cannot port directly code. You cannot use Scilab code in MATLAB or the vice versa. Okay, I think this internet is really poor.
We can see you.
Hello.
Yeah, I can hear
Yeah.
you.
I see. Okay. Okay. So we go to this Julia. They are programming language, not exactly MATLAB like structure. So we see lot many websites claiming many different alternatives, but these are the only three: free mat, GNE Octave, and Scilab, which are similar to MATLAB in that sense. So till the time this Octave is downloading, Maple they are far from MATLAB, so doesn't make much sense here. And there is also one Octave which you can access it online. There is a version of Octave, but again, it's not as much featureful as the offline version. So I would not recommend using. And also, you cannot save things, right? So what we'll do is I'll just start with MATLAB today. So since many of you are not familiar with MATLAB, so I will start with saying that MATLAB is essentially you can also
Can you
use
zoom
it
in a
as a
little?
calculator. This is the most sure, sure.
Zoom. In.
Okay, I'll just let me see what is the option here to zoom. So I think it will be preferences. It's really slow in loading. Yeah, and the command display. Okay, I don't know what. I think it should be in font. Okay, from here, maybe let's make it to not 18, but say somewhere around 14. Okay, now it's fine, right?
Yeah, better.
Yeah. So what we started, let me first show how MATLAB can be used as a calculator. I think there is every tutorial follow this format. So I'm just, so yeah, you can say you are adding 2 plus 5, then it will, and you enter it gives you answer 7. And likewise, 5 into say 7, 5 into 5 is 25, 3 minus 8 is minus 5. So it can be used, and you can also divide, say 4 divided by triple 4, or this, it's a recursive, this one, it will not never end. And at the same time, let me also just install the Octave version so that we can talk about it later. No. Let it run. And then we can also assign variable. So say you want to have a is equal to 5. And if you just press like this, then it will print on the screen is equal to 5. However, if you do a is equal to 5 and then end with a semicolon, then it won't show anything. And then you can a and then enter, it will give you the value of 5. So it can be, you can also assign some value to any variable. And this is a thing which is adopted in every programming language, whichever you see. You will always give some name and assign it some value. In this case, I'm assigning some number, but you can assign even sentences, you can assign words and all that. So say you have a is equal to 5 and then you define something called b is equal to 50 and then use semicolon to just suppress the output. And you can have a plus b. So now you will symbolic it look like a plus b is equal, you are just writing a plus b. However, since you have already defined a before, a will just be substituted, replaced with the value 5, and b will be replaced with value 50. And when you press enter, then it just adds up to give us 55. So that is how it actually does. And what you want, if you want to save result in some variable, then you can have c is equal to a plus b, and then now you have the answer which will be saved in the variable c, and you can always do that, right? So that is one way of doing things. So and there are but say if you have a large number of say uh, you have such a long list of such instructions. So mind you that these are all called instructions. Say when I define a is equal to 5, this is one instruction because I'm asking the computer to to save the value of 5 in the variable a. And similar for b, I'm asking the computer to save the value of 50 and assign it to the variable b. Now, if I perform a plus b, this is the third instruction. I'm asking it to carry out some addition instruction. So likewise, however, if you have say 10 such instructions, say 10, 20, it just goes very large number of instructions, then using like a calculator does not help. What we would essentially like to do in that scenario is to create some file where we say all the values of the instructions and then we can run it. Say I'm just edit and some addition, I'll just call it some edit add. So what when you do this, so there is a key. Two numbers add. So now what I'm doing, I'm able to do is I'm able to create one file where I can have all that. A is equal to 5, b is equal to 10, well, b is equal to say 50, the same example, and then c is equal to a plus b. And now when you run it, you can run from here, editor, run. Then you get a value of 55, c is equal to 55. However, if you do not want to show it, you can just say colon, and then it won't show any result. Now, if you will always see that all the things, all the say variables that are using will always get stored in this workspace here. So workspace will have all the variables and their values stored here. Name of the variable and its value. But say you in a program, you have defined some variable which is say already present here. Then many a time it can lead to conflicts. So even if you have not defined the value prior, it will just pick up values from the workspace, which is not good if you're writing a long program and you may have say some variables already in the workspace. Then in that case, you would always like to clear everything. So when you say write clear and then press enter, it will clear all the variables in the memory. Right now, when you run, so you have a is equal to b and then all that. And say now I define say f is equal to say 4,000. Now again, when I run it, again f is already before there. I mean before we even after we ran the program or we ran the script, we call it. So in this scenario, you would want to have the clear directly here itself in the script itself. Now when you have clear, now you run. So every time before all these instructions are executed, clear function will run, and it will just clear the workspace of all the predefined, all the pre-existing variable and its value. So we have a plus b equals. So this is one way of now. So which means that we can always start from afresh. So our workspace will always be flushed of all the pre-existing variables, and then you run the instruction. So there is how you write a simple script. So this is called a script. And now say you would want to name the script with something so that you can always remember what was this script actually meant for. So you can use this double ampersand sign, sorry, double percentage symbol, and then you can have say that this is a script for adding two numbers, right? So this is essentially the script. So this double percentage will always create something called as a section. So if and say this we had before clear, and you would want that okay, actual process starts from here. So here you can have double ampersand and says add two numbers. And if you want to have comments, say you beforehand you don't know what the value of a actually is, what does a represent, so you can just follow it with a single percentage value and call it this is first number. Likewise for b it will be second number. Now this will be the sum of two numbers, of the two numbers. So which means this comments never gets evaluated. So this will never affect the program. Like the only instructions that will be passed is this. So when you run this script, this always gets automatically ignored. That anything which follows this percentage symbol is considered to be a comment. It won't evaluate. So even if we run the program, we'll receive the same answer as before. It won't change anything, right? So once you have this, so this is how you write a basic script. Now you would want to have something called as a say if you want to do such repetitive activities multiple times, then what you can do is you can define called user defined functions. Say functions, right? And I want to have some function which which I will just give some value, I mean the required values, and it should give us output. So the way we write function is function say some result is equal to, I'm just writing a function for adding two numbers, add two numbers. And then we will give us the first argument, number one, and then number two, right? And then we can have end, which means that our function is closed, and we can have result is equal to number one plus number two, and then close it. So let's just check how it looks like. So C is equal to A plus B. And then let's also write D is equal to add two numbers, first number and second number. Let's see whether the final results are the same or not for C and D. Yeah, we see C is 55 and D is also 55. So which means that you don't need to explicitly write something like this. You can always give any two numbers and then it will add two numbers. And now I'm just doing it for a very, very simple case because you would not require to have a function for such operations as addition because it can anyway be done in this as simple form. But there is just how we can do it things. However, say when you want to have a function, say we want to get some result, and you say that do something interesting. And I just give number one. So what I can have in the result is do some say number one squared plus number 1 to the power, say 44, say number 1, I'll just call plus 0 point, or say 1, right? I'm just something, it does not make much sense, but that's how it is. So some complex operation, say number 1 divided by, say, some 2. This is just arbitrarily something interesting, although it does not seem to be so. So what you'll say is, in this, so for if you were to write this expression for every case, say you were dealing with, say, uh, FG pairs, or say for, you will write such function for F, say for example, G is equal to, say, B to the power, I'll just, this B squared plus then B plus 1 the power 4 plus B divided by 2, right? And likewise, say H is equal to A squared. Now you see how repetitive this sounds. Now, if we were to do something like this for every such number, then it would have been a big, yeah, it would really be very time consuming, as well as it involves a lot of unnecessary efforts. So just to do this, why cannot we cast in the simple form, which is just one expression that you give it input, and it will do that same operation for any number that you provide, and you'll get the output. So that is the way, that is the reason we use such functions to do some repetitive tasks, right? Just to avoid this. So this is like repetition. Repetition. I believe repetition. Likewise here also, it's also a repetition. So essentially, you see, and you can just, you'll have to do for every number that you want, but that's not, if you want to do, if you need to do these operations several times, then that is not the way to go, right? So that's the reason we use functions. Okay. Now what we do is, so this is what we call as the user defined functions. Right? These are user defined functions. However, there will be already inbuilt functions, right? So inbuilt functions are the, so inbuilt functions are when we have already, which are with the functions which already exist. So say we learned that we were unable to use the word, name a function called add. Now let's just see what does actually MATLAB has in add. What does MATLAB do in add? Okay, so this add is a completely different thing to do, right? It's a completely different. So let's just see a common thing to add. The MATLAB has a function called sum, and if you want to know some information about any function, just type the word help space what you want to search for, right? So help sum. So sum gives us this. So sum is the sum of elements, is the sum of the elements of the vector x. If x is a matrix, so what essentially sum does is, so sum tries to make things easier in a sense that, instead of having a is equal to b and a is equal to 5 and b is equal to 50, and then adding up by using all these plus symbols, because this plus symbol only helps if you have just two numbers. But say if you have, say a is equal to 5, b is equal to 50, c is equal to 55, and then when you add all of them and also just add d to it, you see how messy this gets, that you have to use as many uh, plus symbols, as many numbers you have to add, and that often becomes tedious. So one way is, why cannot we have everything into some sort of an array? I'll call number array. So then in an array, we'll just have all these numbers a comma b comma c comma d, right? And then you see that they are all the same. That's a is equal to 5, b is equal to 50, c is equal to 50, or d is equal to 55, right? Now, when you want to sum all of them, just use sum and pass argument as array. So you get the total sum. And this you can assign from before as well to some other number. Some other, say, I'll just assign it to some variable k. I'll use the sum of num array. And now k will have a value of 165. So that is where this inbuilt functions. So these are all inbuilt functions, like functions which are already available in MATLAB. Right? So once you have this, so it means that you know how to do at least about uh, say using inbuilt functions. We are also able to define functions. So the way we define functions, it has to be in this format. Function. What is the function name? Here the function name is add two numbers. What are the arguments, say number one, number two, and what does it return? And return value should be, say, some result. So what is the result? I can name it anything I want. So I can just call it val, and this also val. So but it just should have that anything that you give here as a return, it must be clearly defined in the body of the function. So the function body is this. In this case, the simple function, just one line, right? So this is the body of the function. So any variable in which you want the output to be defined, that should always be clearly defined within the body of the function. So that is the general template. You have to start with function. What is the return value variable name? And is equal to what is the name of the function, what are the argument it takes, define the body, and it should have the return value clearly defined, and then you just end it. So that is the simplest structure of a function, right? Now, so today I would we had also wanted to say learn a little bit more about, say, MATLAB in this case. So we would want to say start solving some problems as well. So before that, let me teach you a little bit, or let's discuss a little bit about using control statements. Edit control statements. Now you'll ask, what are control statements? So essentially, control statements, so these are certain functions. In a sense, it's like you could call it yeah, they are just, yeah, you can call it statements in a loose form, which are used to automate or say run certain tasks which needs to be or which need to be repeatedly carried out. So now I'll ask, okay, it's a mouthful of words here, but what does it actually do? So say I want to write, say our goal is write a script, so to speak, write a script which can print out numbers 1 to 10 without, so I'll just write some obvious statement, without we ourselves typing it out. Of course, we can type numbers 1 to 10, but say what if it's 1 to 100 or 1 to 1000? Like we won't be able to just type it ourselves. So there is where we need to have certain control statements where, I mean, that's one of the use of control statement in a very basic sense. Say before that, I'll just let you know how do you print something on the screen. If you want to print something, say I started with A is equal to 5, and then B is equal to 50, and then you have C is equal to A plus B. Then you have C, right? So when you do this, now even if C has been suppressed, that it will not show it directly, but because we are printing it out using this print function, print is an inbuilt function. So it will just print C on the screen. Okay, sorry. No, sorry. It's print is something which follows from Python or something, right? So Python or other programs. So actually they call it disp. Disp means display. Right? So now when you do it, you'll get the value. See. But what it did is it did not tell us what this value actually is. Like unless we look at the script, we cannot figure out what 55 is. So in that case, we can have C is equal to, yeah. What we are doing is we are essentially having a array of characters, and it will just put the value C. But before that, since C is a number and this is an integer, this would not directly work. It will lead to some problem. Let's see what problem it leads. Yeah, it sees that here what it does is it's giving us the ASCII code for C, which is not the answer. So because the thing is now it's considering C as an integer or as some string, so to speak. So C here will just have some ASCII code, and that is 7. But we want to have the actual value of C. For that, what we'll do is num2 str. So now what we are able to do is we are able to now this is a function which converts any number to string, because the thing is we are going to add it to some other string. Now it will give us the value 55. So this is a convenient way. It's more from a reader, I mean, from a user point of view, that we want to know what result it was giving. So now we can clearly see it's C is equal to 55, and that we have defined from here, right? Now let's just go, and since we know how to print some value on the screen, so now let's say we want to print what we were trying to do. We want to print numbers from 1 to 10. So one simple way is you have something called as for loop. For is a statement, right? It ends with and again. In MATLAB, any such control statement, even function, always ends with this statement called end, or this keyword called end. So what we are trying to do is I'm trying to run, use the control statement called for. It will iterate from I is equal to 1 till 10, and then it will display the value of I on the screen. Now let's just run. Let's see what it gives us. See? So it clearly gave us 1 to 10, 1 to 10. And using just this many, just 3 lines. Otherwise, we have to write I is equal to 1, I is equal to 2, 10, and then say till 10 it would have been still easy. But what if say it's increased to 100? I'm sure coding it up would have taken a lot of time without control statements. So what we do is when we run, we just get up to 100. Now you see clearly able to see all those numbers. So this is one of the control statement, which is called for. And you will see that for is one of the most widely used ones. Whenever we do. So this is called as looping. And for is called, it's like a control loop. So we are looping using for control statement. And here I is the variable that we want to increment with every loop. It needs to be given some value, initial value, and then runs till 100. Now you'll ask me, but where did this double colon comes from? So let's just go back to our command window. This is the command window here. We can all insert all such and just type CLC to clear the screen, but we'll still keep the workspace as it is. It won't be affected, but the thing is the screen would be cleared for the command window. Now say you want to write an array. So one way of writing array is say A, or rather I'll call it A double R is equal to say 1, comma 2, comma 3, comma 4, comma 5, comma 6, comma 7, comma 8. Now you see we had to write type all these letters from sorry, numbers, digits or numbers from 1 to 8, and then we have this array. Say now if you want to have numbers from 1 to say 100 in such array variable, it would have been very tedious to type it out, type it out, right? So then what we do is we use some inbuilt MATLAB operations, such as we call it 1 is to 1 is to 8. So what it does, it starts with 1, takes a step of 1, goes till 8, and then let's see what it gives us. You see, it did the same thing as the above, and we had to print it so less. We had to just type out so little in comparison to the first array. However, in this case, okay, you'll say, okay, it's still of very equal, very say close in that sense that you had to spend similar amount of typing effort. But what about say array is equal to 1 is to 1 is to say 100. See, just this much, using just this many, typing out this much, we could get all these numbers. So now you see the beauty of using all the inbuilt MATLAB. These are all array creators, so to speak. And here what you saw is 1 was the increment. However, say if you want to have increment with some other value, say 2. So now you'll start and get this number. So every successive digit here or number here will be separated from the previous one with a value 2. So you have 1, 3, 5, 7, all the odd numbers. And you want to have even numbers, then start with 2, and then you have all the even numbers. So that's how you build an array. Now, one more thing is that when you have all the numbers with just increment 1. So say I'm writing 1 is to 1 is to 1 is to say 10, so that we are able to see on the screen, right? Now, however, if you are able to do, you can do in this manner also. 1 is to 10. So by default, the increment is always 1. So it will give us 1 is to 10, you see. So now you'll ask why we did this in our for statement. So in for, what we do is for loop always has something called, it takes the variable I takes all the values in this array. So this is essentially an array. Now, if you clearly want to see, okay, how does this work? I'll just still put 1 is to 10, run it. So it gives us 1 is to 10, right? So what it does is this is an array. So instead of 1 is to 10, you can also write, say, A double R is equal to 1 is to 10 outside, and then call I is equal to array, and then still run it. So that is how for loop works. See, you are able to get 1 to 10. So it means that this was just this variable I will take value starting from the first element of the array till the last element. So this is what it does. So that is one control loop that is very useful for us. You'll frequently be using it a lot. Like array in for is a very powerful in the sense that we are clearly able to say where to start and where to end. There are certain more control loops called while. This is also another control loop. It's also used for control loop. And so these are the two in MATLAB. In other languages, you will also in Fortran you'll find one control statement. Control loop, control statement is called do while. In C++, C as well, you have do while. But in MATLAB, you have for and while. And while you will sometimes use when, say, you do not know when a particular loop will end, so you prescribe certain condition for while, and then that loop keeps on going. But in general, for is when you clearly know how many iterations or how many say how many steps a particular loop has to run for, right? So what you do is now we also have something called as a if-else statement. right? So in using if else statements, so if else statement is to evaluate, right? So if else statement is used to evaluate uh, based on certain condition. If like in life also we have similar decisions to make, right? So if something happens, then you will do something, right? Else do something else, right? So that is what we do in if else statement. So say I'll start with if, say a is equal to 10. Yeah, a is equal to, say, I'll just call it, say, 10. And I can always reassign values. Although I have a is equal to 5, I can give it a new value. A is equal to 10 and b is equal to 5. Then if a is greater than b, right, you can have, say, display a is greater than b. Else display b is greater than a. So this is one way of doing things, right? And then you always have to end with and. So it said if a is greater than b, print out on the screen that a is greater than b. Otherwise, just display b is greater than a. So when we run it, we expect a value since a is 10 and b is 5. So by default, if a will be greater than b, then this will evaluate. This will be printed on the screen. And let's do that. You see, you got a is to greater than b. And say now let's change the scenario. Let's call a to be, say, 1 and b to be 5, right? And when we run, now this time a is smaller than b. Now let's see what does it evaluate. So it gives us b is greater than a, right? B is greater than a, right? So this is 1. However, now I'll ask, okay, that's fine. But what about if both have the same value? Let's see what it does. So clear CLC. Let's run. So there is one issue here. The thing is, it already has checked if a is greater than b, which is not true because 5 cannot be greater than 5. Then it just jumps to the else statement and it does anything whatever is written else. It just checks the condition is greater than b, no. Then just type it out. But you see that I have and then here the displays that b is greater than a, which is not true, right? So what in this scenario, what we'll do is we'll also have separate, we can have a nested if else statement. In this case, what we'll have is we'll have else if, say, b is greater than a, then you print this. Right? Else again display b is equal to a. And then again have one more end step. Now you see, now we have been able to clearly define. Now in this case, what will happen is if a is greater than b, which is not true, just skip this part. Now we come to else. Else, again, else also has some more conditions. Now, if b is greater than a, which is also not true because 5 cannot be greater than 5, then we skip this and then come to else. So the only possibility is that b is equal to a, and that's how we'll get in this after executing this problem. Right? So this is how it essentially works, right? So these are like the control loops and also the decision making. So if else is more of a decision making. It's called a decision making. Or you can also call it as conditional statements. Right? For that matter, it's a conditional statement. So yeah, this is what we need to master as of now. I mean, because we'll be using. So what we learned today is so far is we were able to use user-defined functions. We were able to create our user-defined functions, and I saw that we could even use what are the inbuilt functions. And now we also learned something about control statements, right? So this is what I mean. Let's start with today with this much, and let me since so let's see what it after since I have been able to install GNU Octave. So let's see what it gives. Let's see how it runs, right? Incompatible Windows configuration. Windows new terminal is not compatible with. Just for now, let's keep it at that, and let's try to evaluate if we can say open that file that we have been working on, and say are we able to so since I'm installing this for the first time, of course there will be some problems. Our goal is just to run all the script that we just coded up. So till it evaluates, like, so I would like the thing is I would be sharing all these codes in the when you go to the Google Sheet link, which will be sent out by the NPTEL team. You will there will be a presentations folder. In that you have this codes folder. So all the presentations that I'm doing will always be stored here. Within that you will have this codes folder. When you open the codes folder, you will see all those files that I've been working on. So it's accessible to you for that matter. Right, let me use Task Manager to clear it up. Just hanging for long. Just say in task. Yeah, let's run it fresh. Octave. No man, will this say Octave? Let's see what it does. I'll just have. I think there is some issues with this. Okay, maybe I'll just correct it and we'll do this in the next time. No problem. So what we'll be discussing during the next session is like some of the to do things. Is I'll just get back to the iPad and mm, so I'll just share it. So since I do not want to give out too much information just in one day, so what I plan to do is in MATLAB, or even GU Octave. Next time I'll be also using Octave so that we can get a hang of that as well. So the goal is that say we'll start with a simple problem of some simple kinematic problem. So say we have a person is standing here, right? And he just threw a ball up into the air, and then that ball will, and there is always this gravity force acting downwards, and there is a level playing field, sorry, or level ground, right? So it's at the same level. So we want to, and say, let's fix us the starting point here, x-axis and y-axis, from where he just shoots out the ball, right? So we want to compute how the ball moves. So we want to calculate the path, and which is essentially just trajectory, right? Trajectory followed by the ball. And also with some initial velocity. So say some v velocity vector v. When he throws out the ball, there is this vertical, this one. So it's a planar problem. And we need to solve certain differential equation. And as you will recall very well from your school years, that what happens here is v vector is equal to, so I'll just call it v naught vector. So not, because the thing is I'm considering some initial velocity v naught, right? And in general, v vector will be a function of, it will have two components, vx component and vy component, because the component along both the directions, which is given by x dot and y dot. So these are just the, and dot here indicates rate of change. So for just to simplify notations, I'll call it dx by dt and dy by dt, right? So what we'll see is along the x direction, and g here is vertically downward direction. So I'll just call it g vector is equal to minus g of j cap. And mind you that ji is the unit vector along x direction, and j hat is unit vector along y direction, right? So these are the two. So in along x direction, what you have is we have no force. There is no force along x direction, because of which when we say we have because even okay, let me just not to confuse. Let's first write the before that. Let's write the equation of motion. From Newton's second law, we have, let the mass of the ball be m, right? So it is m, then dv vector by dt, this is the rate of change of velocity, is equal to some external force, right? Now, in this case, the only external force which is acting is equal to, in vectorial form, there is only vertical component for the force. There is no horizontal component. So fx external along x-axis, the component is 0. Along y-axis, it is minus g. So this is the force vector. Now, when you use the expansion of here, so what you see is m d by dt vector, which is vx vy, is equal to 0 minus g. And by the property of the equality of matrices, we have that each component must be equal to the other. So which means that this is an important part, because along x direction we had no force, right? So which means that we have two equations. One is m dvx by dt is equal to 0. Another is m dvy by dt is equal to minus g. And when we write in terms of x and y, it is m d squared x by dt squared is equal to 0, and m d square y by dt squared is equal to minus. And remember that the force is actually mass into some acceleration. It's minus mg, so it will be minus mg. Is equal to minus mg. From both sides, since m is always greater than 0, because of which we can just throw m to the right hand side, it just becomes dx by d square is equal to 0. This also m cancels out. We have equal to minus g, right? So I'll just add one more. I'll just write the proper set here, right? So what we have here is the equations are d squared x by dt squared is equal to 0 and d square y by dt squared is equal to minus g. You see, this is also second order in time. So which means you require two initial conditions as per the theory of ordinary differential equations. This is also second order in time. So there's also two initial conditions. So which means that these are the equations of motion, and we require initial conditions. Now, so two initial condition implies that we need to prescribe value for some initial value for x at times t is equal to 0. So x at t is equal to 0 should be something x naught, and x dot or dx by dt at t is equal to 0 should also have some value, some value. Likewise for y as well. So let's write here x t is equal to 0 is how much? When we go to the figure here, we say that, okay, but we have started x, the origin from here itself. This is the origin. So which means that we started the initial position of x is itself the origin. I mean, that's the origin. So which means that the initial condition for x is equal to 0. And when we take a look at the initial velocity, which is dx by dt at t is equal to 0, that is equal to v naught x component, which is already known because the thing is we are throwing at some angle with respect to x-axis. This is already known. So which means that this is equal to Vx, which is just given by magnitude of V naught into cos theta. And for y, we have y as a function of, say, t is equal to 0, is equal to 0, right? And then d of y by dt, t is equal to 0, is the vertical component of velocity, which is we know sine theta. So now we can solve this. In this case, although we can solve it analytically, but we will still solve. We will solve it both numerically and analytically in the next class. So that is the topic that, apart from reviewing the week lectures, we will do this as well. So I think for today we have talked quite a bit. So what we'll do is in week 2, so far what has been discussed is in so far. In week 2, Grashof criteria has been discussed. And we'll talk more about it in the next session. So it just tells us how, or tells us about scenarios when the typical rule, right, of finding out DOFs, number of degrees of freedom, do not work. So it tells us all about all those in a nutshell. That is what Grashof criterion is. So we'll talk at more length in the next session, actually, about Grasshoff's criterion, and we'll just cover more in the next session, and then also attempt solving such this particular problem that I have shown today. So I think with this, we can call it a day for this session. So anyone has any doubts today? I mean, about all this? Like, do you have some doubts?
From my side.
Okay, so say if you have no doubts, then uh, uh, you can. I would just urge you to little explore, say, GNU Octave as part. I mean, in the meanwhile, if possible, and so I'll also try to from the next week onwards. I'll also try to code using both GNU Octave in MATLAB from the next session. And in the meanwhile, just yeah, revise week 2 as well, and also week 3, which will be. So we'll discuss at length from the next week onwards, and also we're talking about some certain numerical methods about how to solve that problem and numerically. So we'll discuss about that as well. So we have lots to do, and the plan is essentially, as I mentioned in the first lecture, that we will try to take up a lot of numerical examples, which involves using softwares, coding. So this gives us a hands-on on robotics, because robotics is essentially a very much a numerical field. So that's why I'm just trying to get head on with numerics from right now itself. So so what I'll do is maybe I'll just wind up the session today, and let's meet the next week in the same time, 6 to 8. So any doubts? Yeah, just you have my email address, which is so Krishna AGR at iisc.ac.in. You can always send me an email on this, right? On this email ID. It collapsed, so let me write it again. So it is Krishna AGR at IISC. So this is where you just need to send me an email, or if possible, I don't know how many of you will be regularly attending. So I would have very much wanted to have some WhatsApp group, but yeah, let's see how it works out. So, so for now, I'll just stop recording.